Hey folks, this video is a little different because you're going to run a lab today without me. Mr. Albright's going to be covering. First thing you need to do is get yourselves in groups of 4. So just sit at a lab bench until there's 4 people at the lab bench, and then everyone can begin. You're going to do this lab in 2 parts. You can do this in either order. One part of the lab is using a motion detector, and the other one is using your phone stopwatch and a tennis ball. So I'm going to explain the motion detector part first. That is more complicated. Each group will have one person use their laptop to set up Logger Pro, making sure that the motion detector is connected and that you're displaying at least a velocity versus time graph. You're going to have someone hold the motion detector so it hangs off of the lab bench and points downward. And then you're going to hold the textbook underneath the motion detector. When you collect data, you'll hit the collect button, and then as soon as you hear the clicks, you can let go of the textbook and it will slam to the ground. The velocity versus time graph it makes is going to look like a hill. There's going to be a spike up and then a spike, and it's going to come back down to 0. The part that you're interested in is the part where it's accelerating downward, which is actually the part that is sloping upward because the motion detector is facing down. So with your mouse, you can click and drag to highlight the part of the graph that has a positive slope. And then you'll go to the menu up top that says Analyze, and then Linear Fit. Once you select that, it will give you the slope of the line that you have highlighted. There are brackets that show up, and you can move the brackets to the left and the right to fine-tune your selection. You only want the part that has a positive slope. Every once in a while, Logger Pro will give you a really large slope that is much bigger than the acceleration due to gravity, which is 9.8. In that case, you just need to redo the trial. It's just because the motion detector had bad timing, basically, and didn't get enough data to give you a good read on the velocity. So do that until you get a velocity graph that gives you an acceleration that is near 9.8. 9.8 is the accepted value of your acceleration, and then whatever value you have is the experimental. The only thing you need to do with this is make a sketch of the graph that you generated in Logger Pro. A sketch doesn't have any numbers on it, so it just has the labels for the axes and the shape of the graph. You should show which part you highlighted, and then you should report the acceleration due to gravity that you determined from Logger Pro. You should do a % error calculation, and you can either Google that or ask Mr. Albright, or maybe I left it up on the board, with 9.8 as your accepted value. And then that's it for now. The other part is the tennis ball part. So you would grab a tennis ball from the front desk, take your phone out, and go to the balcony just right by our classroom, the one that looks over to the field house walkway. One person's going to drop the tennis ball, and the other people are going to time it. And you're timing the time from release to hitting the ground. To be consistent, you want to drop it from a consistent location. So rest your arm on the balcony, and then let go of the ball with your arm touching the balcony. That height I will email to Mr. Albright so he can tell it to you later in the block. But basically, make sure you have your timing down. Time the fall from release to the first hit on the ground. Do that a few times to make sure you're getting consistent results. And then the analysis for that part is to use only the time you record and the actual acceleration due to gravity of 9.8 to determine the displacement of the tennis ball. This part says determine an unknown height. Well, the height of that drop is equal to the displacement of the tennis ball. And so you're going to use the time you recorded to calculate the displacement. So pick an equation, fill it in, find the displacement. The analysis of that is going to be another % error calculation. When Mr. Albright writes the actual height of the balcony on the board, you will use that as your actual value, and then your calculated value is the experimental value. You'll then have 2% error values, and so using those, you're going to decide which method of working with free fall is more accurate. And where it says brief discussion, that just means write 1 or 2 sentences about why you think the more accurate method was the more accurate method. I'm going to put this video up on Google Classroom, so you can watch it again if you want. I wish I had more time to make a more a video with more text on it, but this is just what I had in the time. So good luck, everybody, and I'll see you on Monday.